Hi, this is problem 19 from the 2021 AMC 12B. Regular polygons with 5, 6, 7, and 8 sides are inscribed in the same circle. No two of the polygons share a vertex and no three sides intersect at a common point. At how many points inside the circle do two of their sides intersect? All right, those are pretty large polygons, so that would be difficult to draw. So instead, let's try a simpler problem with 3, 4, and 5-sided polygons to learn how this works. So let's draw up a circle right about here and draw our triangle in blue. Draw up the square in red and the pentagon in black. Now we want to avoid triple intersection points, so let's draw this carefully. All right, that looks pretty good. Now, since we don't have any vertices that intersect and we don't have any triple intersection points, what that means is we can count up the number of intersection points by examining each figure in a pair. So that means we have to look at how the triangle interacts with the square, how the triangle interacts with the pentagon, and how the square interacts with the pentagon. So for the triangle interacting with the square, we see that we have 1, 2, 3, 4, 5, 6, 2 times 3 intersection points between those pair of figures. Between the triangle and the pentagon, we'll have, it looks like 1, 2, 3, 4, 5, 6. So also 2 times 3. And for the square interacting with the pentagon, we'll have 1, 2, 3, 4, 5, 6, 7, 8. So 2 times 4. So when doing these counts, we notice that it's the figure with the smallest number of sides that really dictates the number of intersection points between a pair of figures. So it's the 3 that determines this factor, it's the 3 that determines this factor, and it's the 4 that determines this factor. And that gives us the rule for examining the full problem, because we can break this down again into pairs of figures. So we have the 5-sided figure interacting with the 6-sided figure, the 5 with the 7, 5 with the 8, 6 with the 7, 6 with the 8, and 7 with the 8. But it's the smaller sided figure that's going to determine the number of intersection points between a pair of figures. So in the first case, we'll have 2 times 5 intersection points for 10. In the second case, we'll also have 2 times 5, 10 intersection points, 2 times 5. Now 6 times 2, 12. 6 is the lower number, 12. Now 7 is the lower sided figure, so that gives us 14 intersection points, and the sum total is 68 intersection points for choice E.